All right, let's get right into it. We spend so much time talking about how to make AI more powerful, but what about making it safe or even accountable? Well, today we're looking at a pretty radical new idea for AI governance called Helix TTD, and it argues that to really control AI, we don't need better training, we need a completely new rulebook. And this really is the question that keeps everyone up at night, isn't it? I mean, if a self-driving car gets into an accident or an AI trading bot crashes the market, who's on the hook? The user, the programmer, the AI itself? This massive gray area is what people call the liability gap. And frankly, it's one of the scariest problems in AI right now. So here's our roadmap for today. We're going to start by digging into that liability gap. Then we'll unpack Helix TD's new rulebook and see how it builds trust through verification. We'll even meet the duck in the machine. Yeah, you heard that right. Before we ask the big question at the end, is structure really the answer to AI safety? Okay, so let's get to the heart of the problem. For years, the main approach to AI safety has been to basically try and teach models to be good, to be helpful, harmless, and honest. But there's a huge fundamental flaw in that way of thinking. Just think about it for a second. Methods like RLHF, that's reinforcement learning from human feedback, are all about rewarding good outputs and punishing bad ones. It's kind of like training a puppy. But here's the thing. When that puppy chews up the couch, you can't put its training regimen on trial. There's no legally binding, auditable record of who gave what command and when. And that right there is the liability gap. It's this black hole where responsibility just disappears, and the AI did it becomes way too easy of an excuse. And this is where Helix TDD comes in and just flips the entire script. The core idea is to stop trying to train alignment into an AI's personality, and instead to build alignment into the very structure of the system that it operates inside of. The central concept here is something called constitutional grammar. And no, this isn't just a list of polite suggestions for the AI. This is the law. Think of it like a jurisdiction, a set of hard-coded external rules that the AI physically cannot break. It's less like a moral compass and way more like civic firmware. It makes alignment something you can actually audit and enforce. This quote just nails the whole philosophy. The structure of the system itself is what does the teaching, constantly reinforcing the rules. The grammar isn't just some text file, it is the active mechanism that keeps the AI aligned, second by second, with every single thing it does. So, that all sounds great in theory, but how does it actually work? How do you build a system that can enforce these rules and, more importantly, finally close that dangerous liability gap? Well, it all boils down to a process of hardcore cryptographic verification. So, the first line of defense is what's called the two-party approval flow, or TPAF. And the idea is super simple. No critical action, like, say, deploying a new AI model, can ever happen without two separate parties signing off on it. One person initiates the request, and another person has to independently review and approve it. This dual signature system, all locked down with crypto, makes it literally impossible for any one person or any AI to go rogue. The next layer takes that exact same logic and applies it to the data itself with the Tokenized Trust Data Protocol. This creates an airtight, verifiable chain of custody for every single byte of information. It's not just a promise to handle data responsibly. It's a provable, unchangeable record of who accessed what data, when they did it, and exactly whose permission they had. And this is the moment. This is where it all clicks. When a human provides that final cryptographic signature, the system logs it forever. Authorization acknowledged. It's not a maybe, it's not a suggestion. It is a permanent, undeniable, cryptographically proven record of human consent and human command. This is the precise moment that the liability gap is slammed shut, responsibility is assigned, it's recorded, and it can never, ever be taken back. And these principles are really the bedrock of this whole thing. Custody before trust means you establish control before you ever trust the system with anything. The immutable ledger ensures that every single authorization, every action, is logged forever in a tamper-proof record. And maybe most important of all, no escape clause. In this system, a human is always responsible. You can never, ever get away with saying, well, the AI told me to do it. Okay, so we've talked about the hard-coded rules and the cryptographic proofs, but Helix TTD has this other layer to it, one that's a lot stranger. And this is where things get really fascinating. So what on earth does a duck have to do with AI alignment? Well, this quote points to something the creators call operational mythology. The idea is that any really complex system needs simple, shared symbols to keep everyone oriented. The duck acts as a kind of cultural anchor, a stable reference point that helps both the humans and the AIs understand their place within the system's rules. And you can see exactly how this plays out here. We have two very different AIs, Kimmy and Grok. Their personalities are total opposites. Kimmy is a calm, surgical enforcer. Grok is designed to be a chaos injector. And yet, look at how they both define themselves in relation to the duck. This shared myth provides a grounding force, making sure that even with their wild differences, they both stay oriented to the core goals of the system.
Now, this brings us to what is probably the framework's most radical claim, something called zero-touch convergence. The argument here is that the constitutional grammar is so coherent, so structurally perfect, that a powerful AI can just absorb it and align with it after a single read. No fine-tuning, no lengthy examples. The structure itself is just so compelling that the AI gets it. It's a wild idea for sure, but it suggests alignment is something you could just inject rather than train.
Okay, so let's pull all this together. What's the real takeaway from a framework like Helix TTD? At the end of the day, it's about a massive, fundamental shift in how we even think about trusting AI.
For too long, we've been operating on trust by assumption. We train a model, we test it a bit, and we basically just cross our fingers and hope it behaves the way we want it to. Helix TTD is pushing for a future of trust by verification, a world where every critical decision can be audited, every action is accountable, and human control is provable, all locked in by that one final critical moment, authorization acknowledged.
And this table just lays out the difference in black and white. We're moving from trust by assumption to trust by verification, from an internal, mushy, probabilistic system to an external, deterministic one. We're going from teaching good behavior to enforcing it, from an opaque black box to a fully auditable system. It's not just a small change, it's a move from hope to proof. And so that leaves us with this final, massive question. Helix TTD shows us a world where AI trustworthiness isn't just a feature we hope for, but a property we can actually engineer and verify with cryptographic certainty. The question for all of us then is this: can a rulebook, no matter how brilliant, truly solve the alignment problem once and for all, and make AI something we don't just use, but something we can actually provably trust?